Okay, so hello everybody. My name is Yashar Deldjoo. I completed my PhD within the field of recommender system at Polytechnic di Milano last year. And today it's my pleasure to present our task on movie recommendation under the title of recommending movies using content, which content is the key. And here is the name of other organizers for the task with whom I had the pleasure to basically organize this medieval task. So a few words about necessity of recommendation or video recommendation. So the world we live in today is the movie age or the video age. A large amount of videos are uploaded, consumed, shared through various web channels. And for example, YouTube hosts more than a billion basically videos on its platform, and about 400 hours of videos are uploaded to YouTube just in 1 hour. So this number translates to 3 years of non-stop watching if one wants to watch all videos uploaded to YouTube in 1 minute. The same number holds for Netflix and other platforms. So basically finding novel and relevant videos, movies is becoming harder and harder, and that's what makes the role of recommender system more important and more dominant. So building a recommender system typically involves obtaining some information about users, about the item which we are working with, and basically the interaction of users with items, either implicit or explicit, like ratings, putting them into the system, and then the output is usually presented as a rank list of basically videos, movies suggested to the user as the output. So here's an example of a typical user interaction matrix. As you can see, the matrix is quite big, and it's also very sparse, meaning a lot of entries in this matrix do not have any interaction nor any rating. And so the recommendation task is defined giving this user URM basically for a given user an item whose rating is unknown. Please predict the unknown rating. So this is the rating version of the recommendation. There are also other versions like the ranking version. And this is what we are targeting in this medieval task. So I would like to specify a few words about how the term content is interpreted differently in two communities of recommender system and multimedia, and this is the goal. This is one of the goals we are targeting in defining this task. So the term content is interpreted to comprise of a variety of data sources with which an item can be described. In the core, there is the signal, mainly the audio and visual signal or modalities. And as time goes by, more information about item is added, basically. So we have the expert-generated content, such as genre, style of, or mood of the movie, assigned usually by expert to the content, and the user-generated content, such as tags, reviews, so on and so forth. The thing is, when we go from the inner circle to the outer circle, a few changes occur. We have, for example, a non-semantic representation of the item in the core signal versus semantic. Semantic meaning different interpretation of the items could be expected. We have objective versus subjective. We have no coldest start versus coldest start. So coldest start here meaning if a new item is introduced to the catalog, it doesn't have any metadata, it doesn't have any interaction, so how can we recommend it, right? And then we have credible versus error prone. So credible meaning for the user-generated content, as an example, we need a large amount of data in order to obtain a reliable representation of the item. But the point is in the community of recommender system, the term content for a long time has been considered as the information around the core signal, but not the signal itself. Whereas in multimedia community, extracting features from the core signal is a well-defined and well-established research task. So the main mission we are seeking in this medieval task is to bridge the gap between the two communities of MMRecSys and multimedia. And this is done by integrating audiovisual content features in different content-based recommender system models. And So in particular, the goal of the proposed medieval task is to predict the average and standard deviational ratings, so user rating, through the audiovisual signals of the movies together with metadata. The average rating represents user overall appreciation or disappreciation, and a standard deviation represents user agreement and disagreements when watching a movie. So I would like to emphasize a few words on why we defined the standard deviation of ratings here. So the main idea is that if, in ideal case, a recommender system model could basically represent or model or predict well the differences between user opinions, okay, in a way it's better able to personalize the system, the model, into different opinions basically reflected by the users. So in a way, the variational standard, the deviation of ratings, is a measure of how well we are able to personalize the recommendation. And this is one of the goals usually achieved in the expected in recommender systems. For the data set, most of the work in the movie domain, movie recommendation systems is used by leveraging the movie lens dataset by group lens, which contains millions of ratings for 27K movies given by a large number of users. It also contains user-generated tags and metadata that can serve as baseline for your content-based systems. We are happy to basically introduce two related datasets in the context of this medieval task and our efforts in multimedia recommender systems. The one is, which has been published in MMRecSys conference last year. It's a movie trailer dataset containing, basically, it's a larger scale dataset containing pre-computed audio and visual features. And basically, together with metadata, so this dataset is linked with the movie lens dataset, so it's easy to download it and build basically your content-based or hybrid recommender system. The second one, which is introduced in the context of this medieval task, is a movie clip dataset, which is again another relevant dataset. It uses the same feature, our trailer dataset basically used. I'm going to talk about them, and with the difference that each movie can have several associated clips. So here I would like to play a movie, if it's possible. Just the question is, what differences did you notice? Did you observe on the trailer version of the movie, which was the first, and the second associated clips? In what way did you find them different? Yeah, precisely. That's the goal. So the point is, trailers summarize the entire movie, and so both trailers and clips are made to attract viewers to go to the cinema, to download them, and watch them. Okay, so they're used as an advertising media. The difference is that clips are focused on particular scenes with particular semantics, whereas trailers summarize the entire movie, and they're usually made with a lot of abrupt cuts in order to make it more exciting, right? So that is the main difference, and this medieval task was focused on clips, whereas majority of works on movie recommendation using usually the trailer version or at most the full movie representation of the content. So this is basically it, and then okay, so here is our trailer dataset. You're welcome to download our dataset basically from my homepage on the dataset. It's also available online. So this is a trailer dataset called MMTF14K dataset, and it is basically our dataset introduced in this medieval task uses exactly the same type of content representation as MMTF, but with the difference that for each movie you have several associated clips. So the key question is how we can aggregate this clip level representation into a video level representation. So for the purpose of the content, the content are provided in 3 modalities: audio, visual, together with metadata. In each case, we have a general purpose descriptor and a state-of-the-art descriptor, so-called. For audio, we use block level features, which have had promising performance in music-related tasks like music genre classification. They describe spectral aspect of the audio. And the I vectors, which are built on top of MMRecSys, they use factor analysis. So basically, I vectors are learned; they're not just extracted. They use factor analysis, basically on top of MMRecSys, and they describe theme using a probabilistic model. And then for the visual features, we use a general purpose descriptor called aesthetic visual features, defining color, texture, object in 26 type of descriptors, and pre-computed deep convolutional neural network using AlexNet network. This comes together with metadata, editorial, and user-generated genre tag. So you have a handful of basically content that you can use for different tasks. The development set, as you can see here, are some statistics. The key point is that for each movie, we have several associated clips, both in train and in test set. So on average, we have about 8 to 9 associated clips for each movie. So as for the ground truths, there are 2 prediction tasks. One to predict overall rating, second to predict a standard deviation of rating. And I would like to mention the fact that while user ratings to movies are in a 5-point Likert scale, on half 1 all the way up to 5, user overall rating are continuous. And this continuity is more, let's say, severe in the standard deviation case. So most of the values are quite concentrated around 1. So the key is how we can define models which can distinguish between different standard deviation for different movies, right? And since the target labels are continuous, we use the RMSE as a target output. So basically, people can treat this problem as a classification or as a regression model, depending on what they are interested in, what basically they can achieve. Okay, so regarding the task participation, we have to say this is our first year organizing this task. We really hope we can improve it next year. Originally, we had 15 teams registered. We had a very good start. 5 teams more or less obtained the data, but at the end, we end up in 1 submission, which was an organizer submission. I believe, so this is sad, of course. I believe this is because the final data set that we released was quite late, and this is something we have learned, and we will improve it a lot next year. So we plan to promote this task for next year. We also have in mind to define tasks within MediaEval in which human decision-making is driven by visual and audio content of the movies. Just to give you an example, in fashion domain, but a lot of our decision-making are visual, or in health domain, for example, for food recommendation and tasks like this. Thank you very much for your attention. If there are any questions, I would be happy to discuss it with you.